Okay, welcome back. So, as we said earlier, what we call contextual feature is the feature that you can extract from the sentence in which the ambiguous word is used. So, in a sentence, if you have an ambiguous word, then the surrounding words or the surrounding bag of words can be used for disambiguation, or the part of speech of the neighboring words can be used for disambiguation, or the local collocation can also be used, to disambiguate. All this is a possibility. Now, let me give you an example for each of them. For instance, in this case, you can have, we can say, uh, um, uh, the player hits the ball with a bat. Okay. Now, this is a sentence. Okay. Now, in this sentence, the ambiguous word is bat. Okay. Now, the question is, what are the bag of words that are helpful to disambiguate? So in this case, you can get rid of stop words because we know that stop words do not have a content. So maybe we'll say player is one word. The word hit is another one. The other one is ball. So as you can see, these are a bag of words. Okay, as you can see, some of them might appear before or after the ambiguous word. That's okay. And this is what we call is bag of words. What if I have another sentence? For example, what if I say the bat was used to hit the ball in a baseball game? The bat is used, or a bat is used to behave itself. Now, in this case, again, the ambiguous word is bat, and the bag of words that are used or that can be used as a contextual feature can be the word hit, the word ball, and the word baseball, and the word game. So as you can see, all these words can be used as a bag of words. Mind you, when it comes to a bag of words, it can appear before or after the ambiguous word, and we don't care where it occurs as long as it is within a sentence. Sometimes we can even go beyond the sentence, but within the sentence, collecting content-bearing words is called bag of words. So this is like a bag containing the words. So as you can see, in each of this, for example, in each of this bag of words, the word ball, the word hit, so many ይነግረናል. Maybe the sense of bat in this sentence and the sense of bat in this sentence is the same because the bag of words they contain is overlapping. So this is what we call a surrounding bag of words. The other one is part of speech of the neighboring words. Okay. So what does it mean? Part of speech of the neighboring words. So in this case, we are having determinant. Okay. And here we are having a noun. Here we have a verb. Here we have again a determinant. Here we have a verb. Then a bat is going to be a noun. Okay, important to note. So this is the ambiguous word that we have. So we can talk about, what comes before it. In this case, it appears after a verb. Okay. And here also you can actually have the part of speech for this sentence again. Okay. Article አለን or determinant አለን እዚህ ጋር then a noun አለን then here heat የምንለው አለ verb አለን then we have a noun in baseball is a noun again here also it's a noun so you can see that but appear after a determinant so you can see or you can actually get information about the sense of a word by looking into the part of speech of the neighboring words, okay? What comes before after it, but we are concerned about the part of speech. The other one is what we call local collocation. For instance, what if you have the word interest, okay? The word interest is ambiguous. Sometimes it can be a financial interest, interest, or what we call motivation towards something, okay? So for instance, you can say, I have interest in acting. So what does it mean? I have some kind of feeling towards acting ማለት ነው. Or you can say in the interest of time ልንል እንችላለን. So what does it mean? We are concerned about, concerned about time ማለት ነው. But what if I say the interest rate? So in this case, I'm talking about financial, okay? Okay, it means financial interest እንደማለታችን ነው. So in this case, local collocation means the words that are around it. ስለዚህ whenever you have interest followed by rate, you know that you're talking about financial. Whenever you are talking about interest in ካላችሁ, then it's not a financial. Interest of ካላችሁም it's not financial ማለት ነው. So that's what we call is local collocation. We are looking to words immediately adjacent to the ambiguous word. And what we call the last one, which we call is syntactic relation, is the structure will also help you to resolve. For example, if you say, I saw the saw ብዬ ብጽፍ, okay, in this case, the word saw is ambiguous. It can be the past tense of see, or it can be a material or an equipment we use to cut wood. But in this case, the syntax will help you to disambiguate. In this case, this is a determinant followed by a word, a verb, followed by determinant, then followed by a noun. This is a structure of an English language. So we know that in this structure, the word so would have totally two different meanings. And it is much easier to resolve that using the syntactic relation. So saying this much about the four basic things, let's see each of them separately. Of course, we have seen an example, but it will illustrate it more in the upcoming slides. So what we call surrounding bag of words, surrounding bag of words, we are concerned about unordered, you see? Unordered individual words near the ambiguous word. We collected the list of words that are around the word but, wherever it occurs. It can occur before or after it. And we say unordered because order doesn't matter, whether it appears before or after it. So you can collect words in the same sentence, or sometimes you can also collect words in the same paragraph. Sometimes topic might not be confined to a single sentence, as we have seen earlier. So it gives a general, topic about the context. It tells you the general topic. If you look into the words that are in the surrounding sentence, or even the words in the same sentence, it gives you the topic. So it may use feature selection to determine the smaller set of words that help to discriminate the possible senses. So what we call is feature selection means whether you want to confine within two words before and after it, or within a single sentence, or within two or three sentences in the same paragraph. But most of the time, in this case, stop words will be removed, as we have done it earlier. The other one is the part of speech of the neighboring words. So it means the part of speech means the word classes that are immediate neighbors of the ambiguous word might be helpful. So for instance, if the term P is ambiguous, maybe we want to see the part of speech of one word to the right and one word to the left. Or maybe we want to see two words to the left and two words to the right, okay? So you can use any window. But looking into the part of speech of the neighboring words is one method of identifying the contextual feature. So we call it using the concept of n-gram. N-gram means how many words do you want to see to the left and to the right. So n can be 1, 2, 3, or anything, depending on the size of the window that you want to study. The other one is local collocation. So local collocation is concerned about a specific lexical context immediately adjacent to the ambiguous word. Sometimes words would have their own preference, okay? They have their own preference. If you see the example interest, whenever you say in the interest of, an interest in, kalachu, you are actually referring to, attention or readiness towards something. But whenever you say interest rate or accrued interest or the interest value or whatever, which is associated with a financial term, that it means we are talking about money paid for a use of money, like maybe in the bank or by lending to someone else. So again, the question in here is you can look into a single word context, a two or a three word. So in a way, This is somewhat related to the n-gram model. So how many words are you going to see to the left and to the right of it ማለት ነው? So if it is a single word, then -1 ከዛ ቦታ -1 ብቻ ልናይ እንችላለን, or +1 -2 or +2 ብቻ ልናይ እንችላለን, or you can have two words from -1 up to -2 means 2 to the left, or from -1 up to +1 means 1 to the left and 1 to the right. It means you are having two words, or from the current word, two words, in the next step ማለት ነው, the upcoming two words, 1 and 2 ማለት you have the current word, then the next two words in the ማለት ነው, C1 and C2, and it goes on. Or you can have three words as well. So that's what we call is local collocation. What we call syntactic relation is looking to how word classes behave. For instance, what if the ambiguous word is a verb? Okay. What if the ambiguous word is a verb? So in this case, for an ambiguous verb, it is very important to see the object. Look into the direct object. Mind you, as we said earlier, even though we have 4 contextual feature identification methods, we know that all of them are not sufficient enough by themselves. So it's common to hybridize or integrate, more than one. But the question in here is, if the verb is ambiguous, look into the direct object, or even sometimes the subject also. It will help you to disambiguate. If the ambiguous word is a noun, then look into the verb that, for what kind of object it is a verb to. So look into the verb that is associated with the noun. It will help you to disambiguate. For instance, if you see the word bat, ብለን እንደዚህ ብናስቀምጥ, okay, have a look at this one. bat ብለን hit ብንለውስ ምን ሆነ? We know that bat is ambiguous, but the verb that it is associated with is hit. So whenever it appears with hit, you know that we're talking about the sporting device, አይደለም? ምክንያቱም it is the one that you use. But what if it is associated with fly? So in this case, maybe it is associated with the bird ማለት ነው. So if the noun is ambiguous, look into the verb that comes next to it, and it will help you to disambiguate. If the ambiguous word is adjective, okay, if the ambiguous word is adjective, look into the noun that it is modified, okay, modify የሚያደርገው, okay. For example, have a look at the word close, okay. Close የሚለውን ብታዩት, what does it mean? It can be a verb, because you can say, please close the door, or Abebe closed the door. So it can be a verb, but it can be also adjective, like a close call or a close friend. So if it is an adjective, then look into the noun that it is modifying. Then that will help you to disambiguate. And this is what we mean by lexical feature. So syntactic relation. So most of this information, okay, most of the information that you have seen in here is based on what we call a knowledge base, okay? It is based on a knowledge base. This requires knowledge of the language. The knowledge of the language is the one that tells you what is a direct object, what is a verb, what is the noun that it is modifying. So it will help you to disambiguate. But syntactic relation is another what we call contextual feature that you can use for word sense disambiguation. Now, saying this much about this, the last topic that we're going to see today is to look into a knowledge-based approach for word sense disambiguation. And mind you, if it is knowledge-based, it means it's going to use some of the linguistic knowledge that we have. Now, LESC algorithm is a word sense disambiguation which is developed in 1986, and it tries to identify sense of a word in a context using a concept of definition overlap, okay? So what does it mean? If you are talking about definition overlap, it means you need to have a knowledge base of definition of words, okay? What does it mean? The knowledge base that we are going to use is a definition of words. Sorry, the definition of words should be used as a knowledge base. Okay, you can use the list of words and their definition for word sense disambiguation. That's why we say LESC algorithm is a knowledge-based approach for word sense disambiguation. We are going to see how it works now very clearly. Okay. Okay. Good. Now, how does it work? How does the LESC algorithm work? Mind you, it was developed by Michael Lesk in 1986. So it has three basic steps. The algorithm for LESC algorithm has three basic steps. First, whenever you have an ambiguous word, from MRD ምንለው it means machine readable dictionary. Okay, from a machine readable dictionary. Okay, from a machine readable dictionary, it will retrieve all sense definition of the ambiguous word. You see, it goes to the dictionary and collect or bring all the definition of the words. For instance, if you have the word bad in a sentence, then what it does is from the dictionary, it will bring all definitions of bad. What if on the same sentence, what if you have the word, let's say, close? So what does it mean? It will also bring all the definition of close. So maybe bad might have 5 definitions. Dictionary license now, or close might have 3 definitions. Now, whenever the word bad and the word close are used in the same sentence, mind you, if it is used in the same sentence, it means the context that they are trying to refer to is close to one another. We know that you cannot put them if they are referring to a totally different topic, because in a discussion or in a presentation or in any type of writing, the words that we are going to use in a sentence should be trying to, reflect on some similar topic or similar sense or similar context. So for this reason, the word bad might have 5 definitions and the word close might have 3 definitions. Now, what we are going to do is the LESC algorithm, it requires you first to retrieve all sense definition of the word. Retrieve all the sense definition. Then after that, the second step is determine a definition overlap, which means try to see which of the definition overlaps with the other. ስለዚህ ምን እንላለን ማለት ነው? እዚህ ጋር እንትን እንበለው bat 1 አለ, which means the first definition of bat 2, then bat 3, then we have bat 4, then finally we have bat 5. Okay, so it means bat has 5 definitions. Then the word close, let's say it has 3 definitions, as we said earlier. This is the first definition, then close 3. So the idea in LESC algorithm is once you retrieve all these definitions, perform definition overlap. So what does it mean? Definition overlap means, okay, definition overlap means try to see the common word that you have between bat 1 and close 1. Then count the number of common words between bat 1 and close 2. Then try to find the common words between bat 1 and close 3. Then move to bat 2. Bat 2 and close 1. Then you go to bat 2 and close 2. Then move to bat 2 and close 3. Keep on doing this. Okay? Keep on doing this, Malan. For all the overlaps, የባት ዋና ባቱን ጨረስን አይደል? Then bat 3 with close 1, bat 3 with close 2 with close 3, bat 4 እያለን እንሄዳለን. Now, what we mean by definition overlap is look for the number of common words that they have. Maybe እዚህ ላይ 0 ሊሆን ይችላል, which means they don't have any common words. Mind you, we'll remove stop words here. Here I might have 1, here I might have 1, here I might have 0, here I might have 2, here I might have 1, እንደዚህ እያልኩ እሄዳለሁ. So at the end, for example, forget about the other definitions. In here, you can see that bat 2 and close 2 are having higher overlap, which means they have the definition of bat 2 and the definition of close 2 has 2 words in common. So what does it mean? They are talking about the same topic ማለት ነው. So disambiguate ስናደርግ, we are going to say we are referring to the second definition of bad to end, the second definition of close እንላለን ማለት ነው. This is a concept of definition overlap that we have in list algorithm. And this is a typical example. As we say, the first thing that we do is retrieve the sense definition from the machine readable dictionary, determine definition overlap. So definition overlap means the number of words that they have in common, and finally choose the sense that leads to the highest overlap. So a very simple example is, have a look at the word pine cone. So the word pine has two definitions in the dictionary, and the word cone has three definitions. Now, in this context, mind you, this is a context የምንለው ይሄ ነው, which is given as a sentence or as a phrase. Now, which definition of pine and which definition of cone are we referring to? This is a question. So in this case, what you do is make an overlap. ስለዚህ ምን አደረገ? The first thing that you see in here is the overlap between the first definition of pine and the first definition of cone. So as you can see, the overlap is 0, 11. They don't have any words in common. እዚህ ጋር kind የሚል አለ, we don't have it. Evergreen, we don't have it. Tree, no. Needle, no. Shaped, no. Leaves, there is nothing that they have in common. ስለዚህ 0. What about pine 2 and cone 1? Again, the overlap is 0. You see? Now the other is, what about pine 1 and cone 2? እንወስድ. Pine 1 ማለት ይሄ ነው, cone 2 ማለት ይሄ ነው. So what do we have? Kinds የሚል የለንም, evergreen የሚል የለንም, tree የሚል የለንም, needle የሚል የለንም, ግን shape አለን እዚህ ጋር. You see, shaped ማለት ያው the past tense ስለሆነ these words are referring to the same thing. So what does it mean? The first definition of pine and the second definition of cone has one word overlap ማለት. And this is what we mean by definition overlap. Okay. Now let's see the last one. I mean the important one in here. Now, the one with the highest overlap. So the one with the highest overlap is between pine 1 and cone 3. So pine 1 and cone 3. So what does it mean? Kind, we don't have it in here. Of, it's stop word, we don't consider it. Evergreen የሚል አለው, tree አለው. So as you can see, the two definitions are having two overlaps. So it means that if pine and cone are used in the same sentence, they are referring to the same concept. Now the first definition is kind of evergreen tree with needle-shaped leaves and a fruit of certain evergreen tree. So what does it mean? A pine cone is referring to this specific topic. That's what we mean. So in this case, we'll say where the sense of pine is the first definition and the sense of cone is the third definition in the line. And that is by using the concept of definition overlap, you see? So definition overlap is one of the simplest word sense disambiguation that we have in NLP. Now, what is the problem with the Zaleski algorithm? ምን ይመስላችኋል? Martha, what do you think is the problem with the Zaleski algorithm? Martha? Martha? Martha?
Yes, doctor.
ምን ይመስልሻል the problem?
As I think the problem of this list algorithm is if there is no any common words, it is difficult to gain.
Yeah, disambiguate ማድረግ አቃተኝ ይላል. Common word ከሌለው. That's true. Any other? Any other problem? ዘነበ ወይ መኮንን? ዘነበ
ትክክለኛ የሆነ ሪዛልት ቢገኝም ያው በጣም ታይም ኮንሱሚንግ ነው ብዬ አስባለሁ።
መቼ ነው ታይም ኮንሱም የሚያደርገው?
እነዚህን እያንዳንዱ ለምሳሌ ፓይን ላይ ያው ሁለት አማራጭ ነው ያለው፣ ፓይን 1 እና ፓይን 2። ከዛ ደግሞ ኮን 1 አፕ ቱ 3 ነው ያለው። ስለዚህ እያንዳንዱን ያው ኮምፔር ማድረግ አለብን ውስጥ ሁለቱም ያሉ አለበት
exactly very good now ሁለቱም ትክክል ናቸው ማርታም ዘነበም now the question is what if pine has 10 possible definitions and cone has 12 possible definitions how many overlaps do we have
20 times
how many overlaps
120
120
20 times
so you have to do 120 sentence overlap መስራት አለብን ማለት ነው mind you in the example we had only 2 definition of pine and 3 definition of cone which means 2 times 3 it is a total of 6 overlap but what if a word has more definitions than this እንዳልነው አሁን 10 እና 12 ቢኖራቸው we have to do 120 overlaps አይደለም which is costly but what is even worse is this one take this one as an example let's say that this is a sentence that we have the context ማለት a context means a sentence that's given to you okay now in this sentence we have the word see and if you go to a dictionary the word see has how many definitions
26
man has 11 year has 4 go old has 8 so how many possible definition overlaps do we have 26 times 11 times 4 times 8 times 5 yeah later times 4 times 10 times 8 times 3 and how much would this be
43
okay this number of overlaps ማለት you see 43 million and do you think you have the time to do this overlap
no
it will be really expensive አይደለም
yeah
it's going to take really long for a word sense disambiguation so for this reason creating 43 million sense overlaps or sense combinations would be really difficult because what it does is it will define a combination of word sense in a given context, find a combination of the sense that leads to the highest definition overlap, then it will start from the most frequent sense again for each word. Then in each case, it will replace the sense of the random word in the set with a different sense. So we are going to stop the iteration whenever there is no change on the sense that are selected. So due to this technical problem, the problem of taking too much, they came up with another approach. They call it the simplified Lesk algorithm, and it was proposed in the year 2000. Mind you, the original Lesk algorithm was developed in 1986. So after 14 years, they came up with the simplified Lesk algorithm. And the difference is, instead of performing the overlap between sense definition, mind you, the original one measures the overlap between the sense definition, right? In the simplified form, it performed the overlap between the sense definition and the current context. So instead of between two sense definitions, what it does is the sense definition with the current context. And the current context, what is the current context? What is the current context? The sentence itself. የተሰጠን sentence ማለት ነው. Okay? So in this case, in this case, the context means this one. The current context is this one. The current context means the sentence that is given to you. So instead of comparing the sense of the word see with the sense of, the definition of see with the definition of man, what we do is compare the definition of see with the sentence itself. Check if it has any overlap. Okay, that's what it means. So the search space is going to be significantly reduced. Previously, it was a product, but now, how many comparisons are we going to do? I have 26 sense definitions, okay? I have 26 cents definition of the word see. But what I'm going to do is I will compare that with the input sentence. Okay, with the input sentence, which we call as current context. I'm going to compare it with the input sentence. So how many comparisons do I do in this case?
Only one.
No, 26. ሀ6 compare አደርግና from the ሀ6 select one. Because the word C has 26 definitions. From the 26 definitions, after comparing it with the input sentence, I'm going to select only one. ስለዚህ ምን ማለት ነው? The word C has been disambiguated ማለት ነው. Then what do I do? Move to the word man, which has 11 definitions. So ምን አደርጋለሁ? The 11 definitions, okay, of the word man is compared with the current context. The current context means the input sentence. Then ምን አደርጋለሁ? Select one from the 11 ማለት ነው. You see? In each step, I'm going to select one. So first I'm going to do 26 comparisons. Then after that, I will do 11 comparisons. Then I'm going to do 4 comparisons. So instead of a product, it would be, the number of comparisons would be the sum ማለት ነው. Okay? ይህንን ስንደምረው ደግሞ this is less than 100. So instead of performing 43 million comparisons, I'm going to do less than 100 comparisons using the simplified list algorithm. That's why we say the search space is significantly reduced. Okay? So this is the idea. What if the input sentence that using the simplified list algorithm, what if the input sentence is this one? And does it mean ቢሆንስ? Pine cone hanging in the tree ሚል ቢኖረን. So what do I do? I have the word pine, አይደለ? Which is ambiguous, and I have 2 definitions of pine. So what I'm going to do is pine 1 would be overlapped with the input sentence itself. Mind you, previously ምንድን ነበር ያደረግነው? We used to do pine 1 with cone 1 ነበር አይደለም የምናደርገው? Now we don't have to do that anymore. In a simplified list algorithm, what we are going to do is we will compare the sense definition with the input sentence, or what we call the context. ስለዚህ ምን እናደርጋለን? Pine 1 with the input sentence, then pine 2 again with the input sentence. So pine 1 with the input sentence and pine 2 with the input sentence. So ምን አገኘን? Pine 1 has 1 definition overlap. Then እሱን እንደጨረስን again the same input sentence with the word cone ደግሞ compare እናደርገዋለን. So it means the first definition of cone with the input sentence, the second with the input sentence, and the third with the input sentence. And if you see the definition overlap, ከማጋ overlap አገኘ? Cone 3 with the sentence has overlap. ስለዚህ ምን እንመርጣለን? The definition is pine 1 and cone 3 ነው ብለን we are going to disambiguate. And this is a simplified list algorithm. Okay? So what it does is it will retrieve the from the machine readable dictionary all sense definition of the word to be disambiguated. Then it will perform an overlap between each sense definition and the current context. What we call the current context is the input sentence itself. And this would greatly reduce the search space, which means you can perform the job very fast. But mind you, the accuracy will be compromised. ምክንያቱም instead of the definition, it would depend on the input sentence. Input sentence አችን ደካማ ከሆነ ለዲስambiguation, then we know that we might not get an accurate result. So it is a choice between time and effectiveness ማለት ነው, or efficiency and effectiveness. If you use the original list algorithm, we know that it would be more effective, but it will take time. Okay? Especially whenever you have many ambiguous words. The simplified list algorithm, we know that it is fast, but it might lose some accuracy. So it is a trade-off between the two. The last topic that we have in here is selectional preference. And selectional preference is concerned about words that prefer to occur with a specific type of word. So most verbs prefer the argument that they appear with. And we call that selectional preference, or we call it selectional restriction. So a selectional preference are useful maybe whenever a word is missing in your machine readable dictionary, then their preference might be already encoded, which we are going to see very shortly. Or selectional preference can also be used even to rank phrases based on the sentence structure. So selectional preference is a mechanism to capture or constrain, you see, to capture or constrain a possible meaning of a word in a given context. For instance, the word dish is ambiguous, okay? The word dish is ambiguous. Sometimes it might mean a utensil, sahan ማለት ሊሆን ይችላል, or it might mean a food or a kind of meal. Now, if it appears with cook, if it appears with the word cook, what does it mean? Cook a dish ካልኳችሁ. It means it's referring to a food. Okay? Yeah. What if it occurs with wash? Then it means it's referring to the object. So we know that selectional preference will help you to create such kind of constraint between words. So it captures information about possible relations between a semantic class where the words are associated with this class. So we know that selectional preference can be, extracted from a word sense disambiguation, or a word sense disambiguation. Disambiguation can be done from a selectional preference. So people call it that it has a circular relationship. You can have an annotated corpus to develop selectional preference, or selectional preference can be used to develop a word sense disambiguation. But the feature that we collect might be frequency count, information theory, or class-to-class relationship. And one example would be this one. You can have a frequency count between words with a relation, like word 1 with word 2 and their relation. Or you can have a conditional probability, word 1 with word 2 with this relation, word 2 with this relation blend divide scenario. It tells you whenever word 1 occur, where we already know word 2 has this relation, then the conditional probability can be calculated using a simple probability method. So you can have such kind of methods, like the verb drink can appear with tea, Pepsi, champagne, liquor, liquid, beer, and wine. And if you see their co-occurrence count scenario, you can see that it is most of the time it occurs with tea, Pepsi, and champagne than beer and wine. So whenever drink and scenario, you might say it's more appropriate that it is followed by the word, the noun tea rather than the wine, the word wine and the lalam. So selectional preference will help you to select one word over the other. This already is what we have seen. Dictionary based is